Welcome to homework.
Hello student. So the first part of the question is to show the electronic configuration of sp2 hybridized nitrogen just before the overlapping occurs to make the double bond. So let's sketch it. So here first we'll write the ground state of the nitrogen. So here the nitrogen has the electronic configuration of 1s2, 2s2, 2p3. So this is the ground state electronic configuration. So here, if this is the energy level, so the low energy level is of 2s, which has 2 electrons, just 2 electrons, and one has the 2p, which has 3 suborbitals, which is 1, 2, 3, since there are 3 electrons in 2p. Now, when this, so here the 2s has the spherical structure and 2p has the structure of dumbbell shape like this, and here like this is plus and this is negative, so we'll shade one of it. So this is the pure p orbitals of the 2p. Now when the hybridization takes place, so here the hybridizes, so here the orbitals hybridizes before the formation of bond with another atom. So first it will form the 3 hybridized orbital, which is, so since this is of sp2, so it will form 3 hybridized orbital like this. So here this s will come in hybridized orbital and it has 2 electrons. And now, so as we can see, there are hybridized orbitals of sp2, and when this hybridize, it forms three hybridized orbitals, which is sp2. So since these are sp2 hybridized orbitals and it has electrons, let's count it: 1, 2, 3, 4. So 1, 2, 3 and 4. So this is the sp2 hybridized orbital, and one orbital which is not hybridized is the 2p, and it has 1 electron and it is pure pz orbital. So this is the unhybridized orbital and this is the 3sp2 orbitals, and this is shaped as like this. So here this gets more central, the electrons get more centralized towards one part of the dumbbell shape, so it is being observed like this. And the 2p pure orbital will be has the shape of the perfect dumbbell shape type of a structure, dumbbell shape. So these are the hybridized orbitals of the N before the overlapping of the nitrogen to form the double bond with carbon. Now, so this is the structure of the nitrogen sp2 orbital, and these 3 orbitals are sp2 hybridized, and this is the 2p pure orbital. Now let's move towards the next part of the question. So the next part of the question is to describe the nitrogen carbon double bond. Since here there is one pi bond, so here the pi bond does not formed by hybridization. So here the pi bond does not formed by the hybridization, so it is bond formed by the pure p orbitals of the C and the nitrogen, because these both are sp2 hybridized, so it has one 2p orbital as we have seen above. So let's draw the structure. So these are the sigma bonds of the CH2 and this is of CNH. So here this sphere is of orbital of hydrogen and this hybridized orbital contains one lone pair of nitrogen. So here the lone pair of nitrogen is present in hybridized orbital. Now let's draw the pi bond of the Cn, which is done by the overlapping of the p orbitals. So I'll draw it with different color. So let's draw the p orbitals pure p orbital of carbon and nitrogen as well. So here this is the pure p orbital of carbon, and here this is the pure p orbital of the nitrogen. Now this will overlap like this. So this will overlap in a sideways form and will form the pi bond. So this is the sketch of the CH2NH with pi bond. Now let's move towards the next part of the question. Now the next part of the question is to describe the geometry of the CH2NH. So here, since it has the carbon has sp2 hybridization and here the NH has the sp2 hybridization. So here the sp2 hybridization has the structure of trigonal planar. So here all the hybridized orbitals stay in one plane and the angle between the trigonal planar is 120 degree. So let's draw it. So this is the structure of the trigonal planar of the sp2 hybridized C and N. So here the angle between them is 120 degree. So here the expected bond angle between all the orbital is 120 degree. So here 120 degree and here 120 degree. So this is the answer. I hope you find this video helpful. Thank you.